Let's plot this complex number on this organ plane. So the complex number is 12 plus 12i. So here the real part is 12 and the imaginary part of this complex number is 12. So on the organ plane, we should go 12 units to the right, that is on the real axis. So here it is 12. I can mark this 12. And on the imaginary axis, we should go 12 units, that is 12 units above. So these two intersect at this point. So therefore, we say that this is 12 plus 12i, which we have plotted this on the organ plane. We now determine the polar form of this complex number. So suppose if z equal to x plus yi is the complex number, then this can be written in a polar form as z equals r times of cosine theta plus I sine theta, where r is determined by this formula, that is square root of x squared plus y squared, and theta is given by this formula, tan inverse of y by x. So let's determine r and theta first so that we can write this complex number in polar form. Here the complex number is 12 plus 12i. So let's write down this z equals 12 plus 12i, and therefore x equals 12 and y equals 12. So let's substitute in this formula so that we can determine r. So r equal to x squared, which is 12 squared, plus y, which is also 12 squared, and this we take square root. Here we have a quantity of 12 squared added two times. So instead of squaring up and adding them, I'm going to write down this as 2 times of 12 squared, and then we take the square root. Now this can be written as product of two radicals, that is the square root of 2 times square root of 12 squared, and let's keep the square root of 2 as it is, and then the square root of 12 squared, the square root and the power of 2 will get cancelled, so it's basically 12. So here we get 12 times root 2, and this is r. Now let's determine theta using this formula. So let's substitute y and x into this formula so that we get theta equals tan inverse of y by x. Y is 12 as well as x is also 12. And so this gives tan inverse of 12 by 12 is 1, and tan inverse of 1 is 45 degrees. So now we can write down this complex number in polar form. We utilize this formula to write down the complex number in polar form. Let's substitute the values of r and cosine theta. R and theta. So r equals 12 root 2. So it is 12 times root 2 times cosine 45 plus I sine 45. And so this is the polar form of the complex number, that is z equals 12 times of root 2 cosine 45 plus I sine 45, and we have also determined that r equals 12 root 2 and theta equals 45 degree.